First, I want to thank Phil for the opportunity to be here to talk about my country reality, and it's a really pleasure speak later Carrie, Mike, and Phil. It's a really honor to me. This is my presentation outline. I will talk some topics, and I will start talking about a general overview of the Brazilian market. If you know the McKinsey Global Institute report, probably you know this chart. The report showed this chart 2 times. And if you look for this chart, probably you should be asking by yourself what this guy is doing here, because the situation of Brazil is not good. It really is not good. But to understand better the situation, we have to analyze this chart looking for these 2 axes, the horizontal one and the vertical one. The horizontal one is a comparison among many years, about 10 years, since the 19 to the 2015. And if you look at that, we realize that, yes, we are losing productive during these years. If you highlight this part of the chart, we will see that the United States, Italy, France, and other countries are in the same situation. I think it's the main mission of the probe, because we have to solve this kind of problem, because we have been losing productive during these years. The vertical axis, I think, is not as important than the horizontal one, because here we have a high difference when you compare the countries, because if you realize this part of the chart, we will find the richest countries of the world. And the below part, this part, the developing markets. And it could be a consequence, can be a consequence of the kind of analysis used by this report. The report use the macroeconomic analysis, and productive in macroeconomic analysis is basically the division of the GVA by the man hours, all the labors inscribed in the determinate sector of the economy. Man hours, as you know, is the amount of labor hours involved in some activity. And GVA is the result of the difference between the product value, the final value of the product, and minus the intermediate costs that include labor, material, equipment, and other costs. It means that it represents about 20% of the total capital invested in determined activity. If you spend more money in some activity, probably you have more GVA. It will impact directly in the result of the productive when you are looking for the macroeconomic level. Obviously, we have other problems in my country. For example, the low economic growth during the last 30 years. It's not good, the result that you have been verifying the economy. And governmental inefficiency is not a problem. Bureaucracy is a problem in many countries of the world. We have been trying to change the situation using technology, but we keep having to improve this part. Low public investment and amount of small construction. If you look for the chart, we realize that this is a chart from the annual report of national cement industry in Brazil. And we realize that more than 55% of the total of the retail sales, of the cement in Brazil, are to small contractors or directed for the client. It means that the most part of the construction site in Brazil are small construction sites that are not directly involved with the result of the production. Other thing that I have to highlight is the purchase power parity. It's not a problem, but I have to talk about. And the rate of labor cost material versus material cost. That have a higher influence in the way, the systems that you use in Brazil. The purchase power parity was not considered in the MGI report. It's understandable because if you take, for example, this example, this is on a big house designed by my office some years ago. It's 1,009 100 square meters, looking for the sea, a definite view. And if you take this one and compare to this another one, and a big house in San Francisco with the same level of the finish, we will see that in Brazil, my city, this house costs about $235 by square feet. And in San Francisco, the same house is 13 times more expensive. It's hard to control the situation when you are trying to use this kind of correction. Obviously, it's a picture. We can find many other different situations if you look for. Other thing that I have to highlight is the labor cost, material cost. In Brazil, when you take this data from the International Labor Organization, you find, yes, the worker of the construction in Brazil, the labor cost in Brazil is about, in average, $4 by hour. If you take the same situation in US, it's 40.6. It can vary, and many, if you take, depending on the place that you are, collect this data, you'll be different the value. Could be different the value, but in average, that's it you can find in this side of the International Labor Organization. It is reality in Latin America. In Europe, it's the same, probably about 42. But it have a serious consequence in the kind of structure that you have been designed in my country. But if you take the productive using the national estimator, national construction estimator of the US, and with the equivalent one in Brazil, you realize that the product of these two guys are basically the same. 10% of the difference, not relevant when you make this kind of comparison. The consequence of that is, oh sorry, I have to show this through, is the evaluation of the Brazil average cost construction. It's not the structural, for the concrete structure, it's all the entire construction. The labor cost getting more importance than the material, but when you take this scenario just for the concrete structures in Brazil, you'll see this report. You'll see that the material represents more than 60% of the total cost of the structure in Brazil. It's basically the opposite that happened in the US probably. The consequence of that you have for this kind of situation. Formwork is not the higher cost. In US, probably formwork is the most important cost when you are compound the cost of the structure, a concrete structure, reinforcement concrete structure. But in Brazil, not. Formwork is not a high cost. Non-structural elements use cementitious and ceramic materials, increasing dead loads and creep as a consequence. We use a lot masonry, we use in bricks, with cementitious materials or ceramic materials. It means increase of dead load. Two-way concrete slab with beam as the main structural solution. It means low productive because we have a lot of beams in our structure. And a significant number of conflicts between structural elements and mechanical, electrical, and pumping systems, especially because of the beams. To explain for my clients, for my contractors, to try put my design in numbers, I usually use this kind of methodology. I use 4 index to convert the project, the design in numbers. And we take the concrete volume by structural area. Structural area basically is the 4 area excluding open is bigger than 5 square feet. If you take that, you take concrete volume by structural area, formwork area by structural area, rebar, and post tension. These are the units that I use to do. The first one is so important because if you divide the volume of the concrete of the top, all elements, columns, beams, stairs, by the structural area, we will find the average slab thickness. It's a thickness that represents all the structure. It's good to make sense to understand how much material you are consuming that time-lapse solution. It's good to make sense of the cost too, because you realize the cost of the construction by square meters, by unit of area. If you take this example for, we have it's a multi-story building for about 15 stories. This first solution is so common in Brazil. More than 80% of the structural solutions in Brazil use this kind of structure. It's not a post-tension concrete; it's a reinforcement concrete with beams and slab. This one is a solution more conventional in US, a two-way slab with 8 inches of thickness with post-tension, two-way post-tension in both directions. If you take the inch of that, you will realize that the first inch of the consumer or concrete will be less the first one when you compare it with the second one. Formwork a bit more because you have a lot of formwork to perform these beams. Rebar a bit less, because here I have post-tension. Here I don't have post-tension. The consequence of using this solution is this. This solution is $9 by square feet. This one is $12 by square feet, 30% more. It's hard to justify for the final client that I have to increase the final cost in 30% to find a better solution when you are looking for the constructability, when you're looking for the productivity. Because of that, I have to introduce another concept. Is the concept of the output, the RUP, output per unit of production. In Brazil, you usually invert this equation, use man hours by squared area, structural area. But here, I prefer use this way. Group includes many things, including all that you can preview during the process of the construction of the structure. It's not means that the final time that you will be required to do some activity. The final time probably will be about 30% more than the time measured using the RUP. But basically, RUP means productive. If you can simplify this way, you can understand that. And you have this process. They use it's conventional in construction, in concrete structure. It's pouring concrete, formwork assembly, rebar installation. If you look there, you realize the production to do concrete walls and beam is almost 2 times less than to do as is slab. It means that if you we can propose an index of complexity. The index of complexity is compounded by 4 parts: the formwork of columns, walls, beams, and slab. And I include an effect of 2 to apply those ones that represent, as we see, we have less productive. We have a higher impact in the final productive. Take these ones, I have to apply 2. The consequence, if you compare these 2 units, the inch of complex with hoop, basically the productive, applying 31 multi-story builds designed by my office, I find an average squared of 0.51 and a Pearson of 0.72. It means there's a strong relation between these 2 values. Applying that project that I showed some slides before, I will find for this structure an inch of complexity of 3.2, and for this one, 2.2. It means a productivity of 3.6 square feet by man hours. For this 4.4 square feet by man hours. It means 22% more productive in this solution. I can't show it here. To try to solve this problem, to reduce the cost of the best solution when you are looking for the productive, I rely on these 7 items. Yeah, I will try to talk about each one. The first one is structural concept and formwork system. We have to take modularization seriously. No one just for the elements, but for all the entire structure, including the distance of the column, the span, and all that you are designed in the structure. Limit the amount of different cross section. We can improve the productivity if you keep the same, you don't have a lot of different cross section. It's not have a relevant impact on the cost, especially when you are talking about columns. Modular variation of the slab thickness, I use this kind of solution a lot to increase 2 inches of 5 centimeters in the thickness of the slab, especially in the first floor when you have swimming pools or other kind of loads that are non-conventional when you are talking about the entire building. Mixed wafer and flat slab systems with modular shoring and reshoring. This is a good idea because we save concrete in the middle of the span and keep some strips with the entire section to go with the bending cables of extension. If the solution is linked with modular shoring and reshoring, it's a good thing to improve productive, saving concrete, and keeping the behavior when you are talking about deflection or vibration verifications. Other thing that you use a lot is that solution. It's a kind of growth to increase the PT, to increase PT balance loads. If you look for the equation proposed by T.I. for the balance loads, if you increase F, if you increase the distance between the cable X and the formwork viewing balance loads is good for control deflection and other things linked with the behavior of the post-tension structure. Other things is use the HPC. HPC is a good idea when you are talking about to reduce congestion without significant increase of cost, but take care more than 30% of difference among the concrete of the column and then other elements could be a problem, especially when you are talking about the interface of this element. If you don't have more than 30%, you can concrete the column and the bottom of the slab and concrete the slab without worry about the difference of this concrete. Design transition and special elements with low FC, then specifying the project drawings. I do it a lot because in Brazil we test a lot the concrete. It's so common we find problems in the concrete when you are testing a lot. Because of that, if you take care of the situation and specify a concrete with a high resistance, high strength in the place that you will require a high strength, is good for save problems, for don't have problems, for don't have to put reinforcement, additional reinforcement to solve problems of non-conformities. Product grow fast with the rebar diameter. If you see this sheet, you realize that if you increase the diameter, you increase productive. It's a good thing too because especially the negative rebars, if you use a high diameter, you save problems. If the worker can put the foot above the rebars, and it could be a problem. Other thing you have to take care is about the roots and bands. The roots and bands, if you have a high diameter of rebar, probably you have follow the code, you have a high, you have a space to make the rook perform as the code. And for example, in this case, I have 20 millimeters of rebar with a hook in the end of the connection with the column. If you have 8 inch of the thickness of the slab, probably you have this kind of problem. The rebar will be out of the slab. Other thing that you have been using a lot is this kind of solution. ESTRUTURAL is really a good solution, but it's expensive. I can't justify for my client use of ESTRUTURALs if you can use this kind of solution. It's work well, especially if you use a diameter higher than 10 millimeters, because less than this, you could have problems to keep it stable. Columns with high rate of rebar, more than 2%, never have to be grouped with other with less rates, because it's not good for constructability, because we have a lot of conflicts when you connect the rebars of the slab of the beams above the columns. Other thing that you have been trying to do is mesh and prefabricate reinforcement before out of the construction site. It can be a good idea, but you have to take care with the transportation, especially when you are talking about the reinforcement of the big blocks. You have to understand that these have to go to the construction site. If you don't take care of that, probably this could be a problem. You probably have to change the drawings to solve this problem. Other thing that you have to do to improve the productive is using wafer slab. Probably in the US is not a problem, but in Brazil it's so common we use the wafer slab with reinforcement at the top of the slab. But I trust that if you use the cold pre-compression, that is 1 MPa in Brazil, it's about 140 psi here, no reinforcement is required in the surface of the wafer slab. If you look for this drawing, for this picture, you realize that the stress is concentrated in the top of the columns, where I have a massive section of concrete. And because of that, all the rest of the slab is compressed by pre-compression. Because of that, it's not necessary to use reinforcement at the top of the slab. About post-tension, banded and distributed is the best cable layout in my opinion. Reverse parabola, I use it a lot. Some countries in Europe prefer this kind of layout. Could be a good idea, especially because you have a high space with less variation of the share. But I keep using this. I think it's good for the standard. The balanced loads is a good solution. And this is the kind of layout that I use in my project. The position of the bars and the cable above the columns is critical and requires special attention. I usually use this kind of drawing, this kind of detail in my project, because there are a lot of mistakes when they are the workers are trying to install the rebars and the cables above the columns. Innovative solutions must be considered. I can't specify this in my project, but I think this is important. The post-tension systems have a lot of innovation, and you have to use this to take hands to improve productivity. And the customization and prototyping with 3D printing can easily and help to improve and implement great ideas. Beam is another thing, as was told in the last presentation. We can save time. We can have a good final project well worked if you have a great collaboration of all professionals involved during the design phase. And office construction site communication. This is really important. All the information have to be saved. And I use in my office this tool. ESTRUTURAL is free. You can use this if pay nothing. And it's a good tool to control the informations of the project and the communication with the construction site. Other thing that you have to use in Brazil is the ranking of productive. This company named Impacto is collecting some data on the construction site, and 2 times a year he gives a certificate for the company that performed better in the industry, in the sites that are visited by this company. The result of that is for more than 2,000 cycles of concrete cataloged. This is important because you can give this data for the academy, for other companies, to extract what is important to try to improve process, to find ways to improve the productivity of the sector. Here are some examples. I ever trying to compare this example with that first that I showed, the solution with no post-tension and beams. And you will see that the index of complexity is 34 less than that one, and the cost of the structure is $10 by square feet. The productive is good to 32% more than the first solution. It's the 4th place in that ranking that I showed some slides ago. The result of the picture of the slab. Here's other solution. It's a building with 20 stories. It's a small area, a small structural area. With consequence of that, we have an increase of the cost because we have some walls here that have a lot of consumption of concrete. But we keep the index of complexity good, 31%. Other example is hospital. It's a big area. The first solution of this hospital was using beams and conventional slab with no post-tension. We changed the project. The client was so happy because we saved money in this project, keep the productive good. It's a picture. This building is finished. Other example, here it's a small floor too, but here I have to use, this is in a balcony. We reduce the thickness of the slab in this part of the balcony and have to apply some grooves here. Because of that, I have 2 relations of the span by the thickness of the slab. This one is considered the groove, this another one is considered the groove. This is a tall building. It's 50 stories. I'm finished. It's 50 stories. It's a bit expensive because there are a lot of walls here. But the result was good. It's a complex of 3.2. To finish, I have to talk about that. Getting to net zero. We have this goal to achieve till 2050. And all materials that you take hand to try to reduce the carbon footprint probably will spend a bit more money to use in your solution. And there is a report of the Institute of Civil Engineers of the United Kingdom showed this, redline these 2 things, 2 suggestions for designs that has a grade of 4 in a scale that comes for 1 to 5 of impact, and this have an impact 4. And this impact is include voids and increase utilization factors and design optimization. I think this project was a project in Tennessee. We apply wafer slab here, keeping some strips with massive section. The result, when you are looking for the displacement, is better here. I save concrete, the thickness is the same, and here I have a 0.66 inch of the total displacement, long-term deflection. and here 0.8. I save concrete, I improve my behavior, and save carbon emission, 13% of the carbon emissions. It's green. That's it. Thank you.